All right, welcome back to Kiersey's virtual classroom. We have already done a lot of work to get our stations plotted and our seismograms analyzed. So the last part here, after you basically rinse and repeat for these other stations, is figuring out the magnitude of this earthquake. So epicenter is important, and so is the magnitude. So we are going to be using this Richter magnitude chart, which has a couple of logarithmic scales relating to each other to determine what our Richter magnitude is approximately of this earthquake. Now with real earthquakes, this is a real earthquake, but with earthquakes today, we run through a computer model and we don't do this by hand anymore. So we need to get the lag time, which we've already done, and the amplitude of each of the seismograms. So the amplitude's the one thing we haven't done yet. So to help measure the amplitude, we want to find the highest point, which I've already noted here. And we also need to know the baseline so that you're measuring from the baseline. So that's where the needle point sits before it starts to move in an earthquake. We need to measure from that baseline to the peak. And so you'll use your ruler. I'm using a protractor to measure that. So I have 1, 2, 3. So this is 38.5 millimeters. Okay, because these are centimeters and the small tick marks are millimeters. So my amplitude for this one is 38.5 millimeters. So then I go back to my chart here, and we have amplitude here on the right. We're going to plot approximately where we see 38.5. Again, you're doing a lot of approximations here, so don't worry about getting the exact right answer. It's more about the process and understanding how this works more than getting the exact answer right. Okay? And then we need our lag time. So we calculate our lag time for hops to be 27 seconds. So we're going to plot that here, 27, so they've got 24 right about there, so we'll go a little bit higher for 27. And so these are for hops. Okay, and then last thing to do here is to connect the dots across our magnitude scale in the center there. So just take your ruler and project your line across there. Then we're just going to estimate what that is. So if this is 5 and that's 5.5 because that's 6, we're looking at about a 5.25 for that one. Okay. So then here, I would write underneath that you think your Richter is approximately 5.25 on that scale. You'll do that for each one of these seismograms. And then from there, you will average those. So once you average them, then you can input that information here. But this is an average of all stations. Okay? So this is an average of all of the stations. It's not just one of them. Once you have this number, then you can determine your Mercalli scale. Okay, so with the Mercalli scale, we are going to be using this chart here that takes Richter magnitude and plots it approximately against Mercalli intensity. Now remember, Mercalli intensity is the felt effects, so it's dependent on what somebody feels in an earthquake, not on the scientific data that comes through on seismograms. So we had a 5.25, so we're sitting right about here on the Mercalli scale for our first station, okay? So this is a 6 on the Mercalli scale, and you'll notice it just goes up from there, and then we don't really have a lot that relates magnitude greater than 10 on the Mercalli, or greater than, 8 on the Mercalli. The Mercalli stops right about 8. Okay, so Once you have all of your stations figured out for your Richter magnitude and you average it, you can then figure out what your Mercalli scale is going to be, and then you're all complete. If you have questions, make sure you reach out, but hopefully these videos helped you a little bit.